science, science. Huh, funky, funky science. Oh, funky, funky, funky science, yeah. Oh, funky, funky, funky science, yeah. All right, peace, love, science, science. Huh, funky, funky science. Oh, funky, funky, funky science, yeah. Oh, funky, funky, funky science, yeah. All right, peace, love, science, science. Welcome to Funky Science Story Hour. Thank you for sticking with me, at least those of you who did stick with me. And those of you who didn't, well, anyways, let's just try this again. We're going to start off, as always, with the Funky Science Story Hour theme song. You ready for this, folks? Gather round, my children, pull up a chair, my friends. Let's all get together for the story that never ends. How do we get here? What's inside your head? What's bluer than blue? What's redder than red? Gather around, my people, all children, young and old. Pull up a seat, put up your feet for the greatest story ever told. Science is knowledge and knowledge is power. 'Cause the world is so weird and weirdness is fun. 'Cause there's so much to learn and we've all just begun. Oh, we can learn together. We can understand the weather. We can imagine ourselves in any place. We can see the earth from outer space. How? Oh, with science! Yeah, funky, funky science! Huh. Oh, science! Yeah, funky, funky science! Oh, science, science! Oh, funky, funky science! Oh, we can learn together. We can understand the weather. We can imagine ourselves in any place. We can see the earth from outer space. How do we do that? Oh, with science. Yeah, funky, funky science. Oh, funky, funky, funky science, yeah. Oh, funky, funky, funky science, yeah. Yeah, we're here. We're here. Thank you for sticking with me. Sorry about the technical difficulties. It's so great to be back. It's so great to be on this new platform where once I work out the kinks and the technical complexities and figure out how to get my actual high-tech microphone to work rather than the laptop microphone you're hearing me through now, but hopefully it sounds okay. Does it sound okay? Then it's all going to be so groovy. But this is our new platform is CosmoQuest, which you should check out. It is not only the new host for Funky Science Story Hour, but it's a very cool channel on Twitch that has all kinds of science shows. There's a daily science news update and all kinds of space stuff and morning coffee hours. And you check out the schedule on the CosmoQuest Twitch channel. There's lots of great stuff. And it's a product of the Planetary Science Institute, which is a place that that I work for, and when I have my research hat on, and does a lot of really cool space research and space communication, like what you're watching right now, this CosmoQuest TV. And for the next hour, or what's left of this hour, we're taking over CosmoQuest for the Funky Science Story Hour. And by the way, there's a chat window which you can see up on the side of the screen here, and you can comment, you can ask questions. I got a couple questions that already came in that I want to get to, but I will also attempt to watch for good questions going by. And there's an emoji thing. It's like a star inside of a circle that if you put that symbol at the beginning of your question, then I know it's a question and I'll pay attention to it. And we've got moderators here who are going to help explain that stuff to you as well. So keep those questions rolling in, and we will try to do this, all right? So the first thing I want to talk about was a really cool question that came in from Keon, 10 years old in New York City, who's asked me a few really good questions in the past. Keon, you got it going on, kid. You always ask the best questions on Funky Science Story Hour. See that in the chat window? They're telling you how to precede your questions. Pay attention to that, because that will alert us to the fact that you are asking a question that wants to be addressed by the powers that be here at the Funky Science Story Hour. By the way, I'm David Grinspoon. Some people call me DrFunkySpoon. I don't care what you call me as long as you call me. Why don't you ever call me anymore? All right, so the question that Keon asks is, what elements are in trees? What elements are there in trees? And that's such a great question, and I love how it follows on to what we were talking about in last week's Funky Science Story Hour, when we were talking about what elements are and the way chemistry works. You remember that? Elements, if you look at matter and you break up matter into smaller and smaller pieces, eventually you get to things that are the smallest things there are, almost, called atoms. Atoms aren't really the smallest things there are, but you remember they're the smallest things in which the elements still have their personalities. If you take some carbon or some iron and you cut it smaller and smaller and smaller, the smallest thing you get that's still carbon or still iron is an atom. And the way those atoms of different elements interact and bond together, grab onto each other and form partnerships and associations, that's chemistry, and that defines so much of the way our world works. And there's chemistry in everything. And so the question, what elements are in trees, is a really cool one. Let's talk about it. So there are certain elements that are in all life, at least all life on Earth. We can talk about, it's another interesting question, whether those same elements that we find in all life on Earth should also be in life on other planets or elsewhere in the universe. Some scientists think that they should be. And the reason is because of chemistry, because of what we were talking about last time. So first of all, let me tell you what elements there are in trees and in human beings and in dogs and cats and bacteria and viruses, and basically all life has the same small set of elements that are key. Let me go over to the magic Funky Science Story Hour screen. You may not realize it, but we're very high tech on this show. And this is one of the pieces of magic we have. By the way, since last time I did this cool display, that I'm working on with all my magnets. See, you saw a little bit of that in the intro video, little funky science story hour magic here. But let's talk about elements in trees. Okay, so there is a small set of elements that does most of the important chemical work in all of life. It's amazing how small a set it is, considering the diversity of life and all the different chemicals inside us and inside of trees that make life happen, that make the magic happen. But it's something we call chansp. Why do we call it chansp? Because these are the elements: carbon, hydrogen, oxygen, nitrogen, N, phosphorus, and sulfur. How would you pronounce that? I pronounce it chomps. Chomps. Anyways. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Those are the elements in trees and in you and basically all life. Okay, there's a few others. In fact, there's a lot of others in what we call trace amounts, tiny little bits of other things like iron, which is Fe, and magnesium, which is Mg, and calcium, which is Ca. And, you can go on. There's a whole long list of things, even some weird things like zinc, the list goes on. But these are trace elements, tiny little bits. But most of the stuff, well, sorry, I didn't mean to spit on you. I get excited when I'm talking about elements. Most of the stuff in trees and in you is this chunks, this carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. That is almost all the stuff in trees. And it all gets combined in different ways by those chemical bonds we were talking about last time, which is just the atoms getting together with each other and sharing their electrons and trading their electrons back and forth and saying, hey, it's almost like they're playing cards and somebody says, hey, I got an ace. Anybody got a king? And they're trading cards back and forth. Only the elements are going, hey, I've got 2 extra electrons. Anybody need 2 electrons? And the oxygen will go up to the carbon and go, yeah, man, if you can share those electrons with me, we can both be stronger. And that's how chemistry happens. And so all of that stuff in the tree, the bark, the sap, the wood, the leaves, the roots, all that stuff is made up of different combinations of mostly just carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. Chomps. And some of it is really neat the way they combine. Because if you think about it, these trees out in nature, they're always exchanging matter with the rest of the earth. Think about what a tree's doing. We talked about this a little bit when we talked about the carbon cycle. Remember, we talked about the carbon cycle in the atmosphere and how there's carbon dioxide in the air, which is a carbon and 2 oxygens, like that, in a straight line. It's not like, you remember we talked about a water molecule, which is not a straight line. It's the oxygen with the 2 hydrogens at a funny angle. Well, a carbon dioxide molecule is in a straight line, and when it's in the air, it's vibrating all around, and that vibration is why, remember, a carbon dioxide molecule in the atmosphere will absorb infrared radiation. We talked about that, and that is why the Earth is as warm as it is, because of all that carbon dioxide and some other molecules in the atmosphere absorbing the infrared radiation, keeping that radiation from going back out into space, right? So it's very important. It's good that we have carbon dioxide in our atmosphere. Without it, the Earth would be so cold we'd all freeze. There wouldn't be life here. But with too much carbon dioxide in the atmosphere, the earth starts to warm up. And that's the problem we talked about with global warming. Putting too much carbon dioxide into the atmosphere from the smokestacks on our factories and the tailpipes of our cars. So we're worried about that now. But I'll tell you, the reason I'm heading back to the topic of trees, because one really cool thing that trees do is they absorb carbon dioxide from the atmosphere. All the time, trees are taking in carbon dioxide and they're breaking it up. They're breaking it up. They're saying, we don't need, where'd my eraser go? Oh my God, another technical emergency. Oh, here it is. They're saying, we don't need these oxygens. We just want this carbon because we're going to turn it into organic matter. And organic matter, you have carbon, 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 lots of carbons in a row. And then you have other stuff too. You have some nitrogens and you have some oxygens and a little bit of phosphorus and sulfur, all different combinations. But it always starts with carbon in these chains, chained together. That's what you're made out of. That's what I'm made of. That's what trees are made out of. Different combinations of carbon molecules. That's what we mean when we say an organic molecule, which is the stuff that life is made out of, is complicated molecules, much bigger than this. Some of them have hundreds or even thousands of carbons. They can be huge. They're things like we talked about proteins, DNA, but it all starts off with carbon. And the way the trees get that carbon is they pull carbon dioxide out of the atmosphere, the CO2, and they say, get out of here, oxygen. We just want your carbon. And they use solar energy. They use solar energy to break those bonds. The sunlight comes in and it's zap, get rid of the oxygen and just use the carbon. And that's cool for us. That's cool for a couple of reasons. One, what happens to that oxygen when the trees get rid of it? It goes into the atmosphere as O2. O2, or if you draw a picture of the molecule, there are two oxygens with a double bond between them. And that O2 goes into the atmosphere, and that's what we breathe. So the carbon from CO2 gets pulled into the trees. They discard the oxygen as waste material. But we go, hey, wait a minute. You're not eating that oxygen? You don't want that? Don't waste it. I'll breathe it. And the animals can breathe in that O2, that oxygen. And so the byproduct of the trees pulling in that carbon to make tree stuff is that they get rid of the oxygen. And that goes into the atmosphere as O2. And we breathe it. And then it gets even cooler because, when we breathe O2, what are we doing with that? We're using that oxygen to, essentially, we're burning food inside of us, which sounds weird, but we're doing it slowly. It's a slow burn, the chemical factories inside our cells. And we take organic molecules, a lot of which comes from trees, in the form of fruits and vegetables and all that stuff, organic molecules made in trees and plants, and we react it with O2 inside of us, and we breathe out the CO2. So the trees take the oxygens off of the CO2. They say, we just want the carbon, and they build stuff, and they get rid of the oxygen. It goes into the atmosphere as O2. And then the animals come along, and they eat stuff that's made in trees and plants that are doing that, and they react it, they breathe in the O2 that the trees put out, and inside of us, the O2 goes back in to react with those carbon molecules, and we breathe out CO2. And then that CO2 goes into the atmosphere, and another tree can grab it, and so it's a big cycle of carbon with animals and plants and trees. And they're all trading around the carbon, and the oxygen gets tossed back and forth between O2 and CO2 and between trees and humans. So the carbon in trees comes from the air, and it goes back to the air when we breathe it out. It's a big old cycle that humans, or all animals, we call that respiration, breathing in oxygen, burning food. We get energy from that. That's how we get energy, from that food reacting with that oxygen. And then we breathe out the CO2, And the trees use energy from sunlight to break up that CO2 and start the whole cycle over and over and over again. It's a beautiful thing about life on Earth. And it has to do with the question you asked, Keon, about the elements in trees. Let me tell you one more cool thing about elements in trees. There's a funny thing about nitrogen in the chomps here, the carbon, the hydrogen, oxygen, the nitrogen, the phosphorus, and the sulfur. Those are the elements in the trees, in the people, and all the animals on Earth. Plus a lot of little mixture of, little pinch of salt and pepper and other spices and other elements. But basically, these are the main elements. And that nitrogen is really important. And here's a funny thing. What you might ask, where does a tree get nitrogen? And if you've been paying attention to Funky Science Story Hour, you might say, well, I know where the tree gets nitrogen. Because the air that we breathe, yeah, it's got a tiny little bit of carbon dioxide. Trace amount, just a smidge of carbon dioxide. And it's got about 20% of oxygen, O2. But the air that we breathe is mostly nitrogen, N2, right? You know that if you're a regular viewer of Funky Science Story Hour, right? So the air we breathe is mostly nitrogen, but the question is, so then isn't it obvious that the trees can just get their nitrogen from the air? No, because the funny thing is most of that nitrogen is in a form that no life can use. It's sort of a paradox because the nitrogen in the atmosphere, and this has to do with the chemical bonds we talked about last time. The nitrogen in the atmosphere, it's an N2 molecule. And N2, it turns out that you have two nitrogen atoms, and then they have what we call a triple bond. It's a really strong chemical bond between those nitrogens. And it's so strong that almost nothing can break it. So trees, I told you how trees can break CO2. They use solar energy, and we call that photosynthesis. And they pull off the carbon, and they go, oh, great, carbon. I'm going to make myself into a tree. And the trees need nitrogen. Everything that's living needs nitrogen. Nitrogen is an important part of proteins and amino acids. It's an essential element for life. But here's the weird thing. These N2 molecules in the atmosphere with these two nitrogen atoms triple bonded together, that bond is so strong that it's almost impossible to break. A tree can't just come along in sunlight. Sunlight is not strong enough to break up that N2. So it could be a problem for life. All that, it's like, that poem, The Rime of the Ancient Mariner, that goes, water, water everywhere, but not a drop to drink. That's because the ancient mariner was in the middle of the ocean and so thirsty, but you can't drink salt water. It's in the wrong form. Well, in this case, it's nitrogen everywhere, but not a bit that a tree can use. So all this, the air is mostly nitrogen, but it's in these N2 molecules that are almost impossible to break. So what's the deal? How do trees get nitrogen? It turns out there are two ways. One is, what's the most powerful thing you can think of in the atmosphere? More powerful than sunlight. Something that comes along once in a while and just like, it's lightning, right? Imagine how powerful lightning is when it comes through the atmosphere. Well, it turns out that when lightning strikes in the atmosphere, it heats up air so much that it actually breaks up nitrogen molecules into nitrogen atoms and things we call ions. But anyways, lightning, a bolt of lightning is so strong that when you have lightning, it breaks up nitrogen and it puts it in a form that life can use it. So lightning is one of two ways that life can get nitrogen out of the air so that trees can have nitrogen. The other way is there's a kind of bacteria called nitrogen-fixing bacteria. It's funny that they're called fixing because what they really do is break things. They can break the bonds of nitrogen. But there are bacteria that have figured out these very ingenious ways to break up nitrogen molecules and create things like nitrates and nitriles. It doesn't matter, but they break up the nitrogen bonds and they put nitrogen in a usable form so that it can go into amino acids and proteins and become parts of trees. So just kind of a fun fact, even though the air is mostly nitrogen, almost all that nitrogen is in a form that is impossible for life to use. And if it wasn't for lightning or for these little nitrogen-fixing bacteria, there might be no life on Earth because life needs nitrogen. So anyways, that's basically the deal, Keon, with the elements in trees. Great question. Thank you for that. Let's see. Do we have any more questions that have come in? Let me look at my little chat thingy here. We have, oh yeah, exactly. To get nitrogen from air, oxygen has to use anaerobic bacteria and or lightning. Trees are so good. I agree. Plants are so good. Massive amounts of, can't we just plant, here's a question. Can't we just plant massive amounts of trees and plants to solve the problem? That's a good question because I mentioned before about the fact that carbon dioxide, where we go? I mentioned before the fact that carbon dioxide is pulled out of the air by trees. So in theory, couldn't we solve the whole global warming problem by planting trees? Well, in theory, yes, you could. But it's basically a big math problem. If you add up the amount of carbon dioxide we're putting into the atmosphere now from all our cars and all our smokestacks and all the other, the coal and the industry and all the stuff we're doing to add carbon dioxide to the atmosphere. You can, if you want, you can figure that out roughly in terms of, we talk about gigatons of carbon, which is like a giga, it means a billion. So a gigaton is a huge amount. That's a billion tons of carbon dioxide. And it's a lot. And you can actually calculate, I'm not going to try to do the math for you right now, I'm just going to explain it. You can calculate how much one tree removes of carbon dioxide over, say, a year compared to how much carbon dioxide is being put into the atmosphere by all the human activities. And then you can say, okay, what about a whole forest? How many trees are in a forest and how much area would that take up? And then you can say, okay, how much of the earth would you have to cover in forest to be removing enough of the CO2 from the atmosphere and turning it into tree stuff so that you can solve the problem? And the answer is too much. You can't really do it with trees. I mean, theoretically, you could if you can cover some absurd percentage of the earth with trees. And it does make a dent. One way that we can help with global warming is to plant trees. It does help. It moves things in the right direction. But if you want to know, can we just keep driving our cars and doing everything and not worry about it if we just plant lots of trees? It's not enough. It doesn't add up. So with climate change, we have to do all of the above. We have to stop driving as much. We have to stop using as much coal in factories. In fact, we should stop coal completely and use alternative energy, use sunlight and other forms of energy. And we should be planting trees. But you can't solve the problem with just planting trees. We have to do all the different things we can do. Another complication of it is, if you think about it, what happens when you cut down that tree? Say you cut down that tree and you use it in your fireplace. Well, it doesn't help at all, because when you burn that tree in your fireplace, you're turning the carbon in the wood back into carbon dioxide, right? So you have to plant trees, and then you have to leave that area forested. Or if you do, for some reason, cut down those trees, don't burn them, just bury them, or we say sequester them, do something with them so that that carbon does not return to the atmosphere as carbon dioxide. Okay, so maybe that's enough about trees and carbon. And let me just see what happened to my my little chat window thing there that I could look at. Oh, here it is. That was a good one, though. This is important and fun stuff to talk about. Yeah. I'm sorry about the beginning of this show got truncated because we were still working out the technical details. I'm learning how to use this platform, and I had a problem with my microphone. Now I'm just using the laptop microphone, and I hope it sounds okay. I want to get your feedback, and you can send me a message on Facebook after the show or during the show or whatever, and let me know how the audio was, because I'm gonna try to get it to be better in the future. I'm also noticing that the time is running short, and today I'm gonna stop Funky Science Story Hour right at 4, even though we started late. And the reason why is because there's something potentially very exciting happening today, which is a rocket launch. Not just any rocket launch, but the first time that astronauts are being launched from the United States in many, many years. The return of the ability of the U.S. to send astronauts into space. We used to have the space shuttle. Before that, we had the Apollo and all these other great rockets. And then for a long time after the space shuttle, the U.S. has not been able to launch astronauts at all. We've been partnering with Russians and with Europeans and people in other countries, but we have not had any American launch ability. But today, depending on what's happening with the weather, and I gather the weather might not be so great, so it might get called off for another day. But at any rate, there's this excitement about this rocket launch today that's very, very historically important. And because of that, exactly at 4, this stream, I'm going to stop because on CosmoQuest, they're going to be covering the excitement around that launch. And so you can keep watching this channel and learn more about that. But I'm going to stop in just a few minutes because of that. But at any rate, I want to mention again that CosmoQuest is the platform. In addition to my show now, there's cool stuff every day. There's space news and morning coffee chats and all kinds of really great space content. So you should check it out. And that is it's sponsored by Planetary Space Institute, which is a really cool science research and educational institution. And since we only have a few more minutes, I'm going to go out with a Funky Science theme song, and then I will see you guys next week. And until then, peace, love, and science. All right. Here we go. Gotta be in tune, because this is funky science, but we don't want to be too funky, right? Gather around, my children, pull up a chair, my friends. Let's all get together for the story that never ends. How do we get here? What's inside your head? What's bluer than blue? What's redder than red? Gather around, my people, all children young and old. Pull up a seat, put up your feet for the greatest story ever told. Funky Science Story Hour, 'cause science is knowledge and knowledge is power. Because the world is so weird, and weirdness is fun, and there's so much to learn, and we've all just begun. Oh, we can learn together, we can understand the weather, we can imagine ourselves We can see the Earth from outer space. Huh? Whoa, with science. Huh, funky, funky science. Oh, science, science. Yeah, funky, funky science. Oh, funky, funky, funky science, yeah. Oh, with science. Yeah. Huh, funky, funky science. Yeah, funky, funky, funky science, yeah. Oh, funky, 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 funky science, yeah. All right. Thank you very much. I'll see you guys next time. Peace out.